individual gas law known as Charles's law, and Charles specifically looked at the relationship between volume and temperature. So when Charles was working and studying the relationship between the volume and temperature of a gas, during his experiments, the pressure and the number of moles of the gas were held constant, not allowed to change. So take a look here. So he would measure the temperature of the gas and measure the volume. And then he would heat the sample of gas, record a new temperature and the new volume. And so take a look. So as he heated up the sample, the gas wanted to occupy more space. So his law states that as the temperature of a gas increases, the volume that the gas needs to occupy also increases. So in this case, as we see an increase in the temperature or an increase in the x coordinate, we will also see an increase in the y. So in this case, because they increase or decrease together, we refer to this as a direct relationship. And so when you plot the data, or if you have to sketch it, then we would see an ascending linear line. Taking a look at examples here. So what happens to a car's tire in the winter? So when you think about winter conditions, this is when we tend to experience really low temperatures. So compared to the summertime, the winters, we see a decrease in the temperature. And sometimes if the temperature is low enough, you go outside and you look at the tires on your car, they could look like they're slightly flat. So that decrease in the temperature, the gas occupies less space. So therefore, the volume occupied by the gas in those tires has decreased. Now, once again, if we know the starting temperature and volume and we change the temperature, we can mathematically predict the new volume that the gas will occupy. Okay, so here we go. And when we look at this question, a gas occupies 22.4 liters at 273 kelvins. Pressure and number of moles are constant. What volume will the gas occupy at this new temperature? So when you go from T1 to T2, we see an increase in the temperature. And if the temperature increases, that means we should also see an increase in the volume. So that means that V2 must be a larger value than V1. So mathematically, let's solve for this. So our equation is V1 over T1 equals V2 over T2. So for V1, we put in the 22.4 liters divided by T1, because this is being held at 273 kelvins, equals, well, V2 is what we're trying to figure out. What will be the volume when the gas sample's temperature reaches 350 kelvins? Because we have two fractions set equal to each other, that means mathematically you need to cross this temperature that's in the denominator on the right up and cross multiply it by the numerator up at the top to solve for V2. So when you solve for V2, your calculated answer is 28.7 liters. And 28.7 liters is larger than 22.4. So mathematically, that would make sense. If you're having trouble with the inputting the data on your calculator, please see me for help.